Hi, welcome back. The topic for today is to take a look into handling HTTP requests in Clojure. The idea is not to give a full overview of all possible libraries, but to really focus on some simple libraries like Ring and Compojure, and to understand how these pieces works together and what are the responsibilities of these libraries. So I prepared this high-level overview here, a diagram. So this box represents our application, and then we have users that do HTTP requests from the outside. Let's take a look what we have inside our application. So the core of our application is an HTTP web server, and we are not writing it from scratch as we are in Java ecosystem. We basically rely on popular existing solutions for that. So there are multiple options available like Jetty, Netty, etc. From my experience, one of the most popular option is Jetty, and I guess one of the reasons is because Ring provides a Jetty adapter, but we'll talk about that in a sec. So we have this HTTP web server to do heavy lifting for us, to scale internal thread pool, to handle requests based on load, and any other properties you can think about a web server. So that's done. After that, we have a Ring HTTP abstraction, and we'll talk about that in a sec in more details. But basically, it converts requests that we receive into Clojure maps to represent a request in a simple format, and after that, a response will be as well a Clojure map to provide the response back to the web server. And in the middle, as you can see, there is a Ring Jetty adapter, and this is a library that will connect our Ring abstraction and our Jetty web server. So the Ring adapter will know how to start the embedded Jetty server and how to convert Jetty classes and servlets into Ring abstractions. So we can use Ring to handle our requests. So when we receive a request, it goes through a chain of middlewares in Ring, and a middleware is basically just same handler, but it will add additional functionality on top of our main handler at the end. And eventually, in some real scenario, we'll have some kind of HTTP router, and it will basically know based on the path of the request and on the HTTP method, which handler should be executed to handle our request. So that's a top-level overview. Let's jump to our editor, and I prepared some examples here. So let's start with the first section, which is a web server. And as I said, we are using existing libraries from Java ecosystem. And here you can see an example how to spin a Jetty embedded server in plain Java. So we have a main function here, and we basically creating a new server on some port, and then we create a handler, and then we add our servlet mapping. And as you can see here, we use this example servlet class, and we map it to this path in the HTTP requests. And the servlet is defined here. It extends this HTTP servlet, and we have this do-get method inside, and we have request, and we have response. And the idea of this function to process the request and prepare the response. It looks pretty simple here, except that there are Java classes that really complex inside. But the problem that if we want to use it from Clojure, it will require quite a lot of Java interop, and it will be really annoying to write that each time in this format. So we have Ring library which is an abstraction. So we have 4 core bits in Ring. It is request, response, handler, and the middleware. And let's take a look starting from the request. So request is just a Clojure map that's supposed to represent an incoming HTTP request. And the common keys in that map will be this list. It will be server port, server name, address, URI, query string, scheme, request method, headers, and body. And you can see example here that I got from the REPL. You can ignore the content from the headers because that could be different for each HTTP request. But if you take a look into HTTP spec for the requests, the names will be really similar to what Ring has, and it's really easy to match what we have in Ring abstraction defined and what we have in HTTP request abstraction protocol defined. So this map is what our Clojure code that's supposed to handle a request will receive eventually, so we can get all the data we need from this map. So Ring response is even simpler than that. So we have status, headers, and body. And if you know how HTTP works, you should understand that straight away. So we have the status. It could be like 200 for successful request, 404 for not found, 500 for some exception, etc. We have headers, standard HTTP headers that we want to return from our handlers. And then we have the body, right? And body could be different types, but in simple case, what we usually want is, for example, if we return text/HTML, we will have a string that represents the HTML inside a string. If we're building some kind of API, it will be header application JSON, and then we have the body string that that has encoded JSON into a string inside. So that's responses. And after that, we have handlers, and that's where we write our logic to process the request. So the handler is just a Clojure function, and the input will be the request, and it will be that map that we saw in the example previously. And after that, we can write whatever logic we want based on that input. And after that, at the end, we provide the return value, and that should be a response that's defined in this Ring response spec. So that's handler. Slightly more complex concept is the middleware, but it's also pretty easy to understand. So it's a high-level function, and it basically, the purpose of that is to add extra potentially common functionality to our handlers. So let's take a look into this example. We have a middleware that's called wrap content type, and the middleware should always have the handler as the first argument, and then we can put whatever extra properties we need to configure the middleware how we want. It depends on you, basically, when you write your middleware. So when we have the handler, we return from the middleware a new function that's basically the same structure as our handler. So it should get the request, and it should return a response back. And so in the middle, we call handler on top of the request. So we have an option here to extend our request. So if we want to add more data to the request that will be passed to our eventual handler, we can do it here. And also we have access to the response. So if we want to transform the response in some way, we can do it here as well. So in this particular case, we don't change the request. So we just execute handler on top of the request. But after that, in the response, we want to change the headers content type header to some content type that we provide here. And the usage is really simple. So this is our main handler, and then we use these interceptors to chain them. So we use this threading macro, so the handler will be always passed as the first argument in this chain. So this handler will go right here, and then this will go here, and so on. And that's how we combine the middleware. Obviously, the order of this is important, because if your middleware depends on some state that was added by other middleware, it should go after in the chain. So yeah, that's enough theory, I think. Let's jump into our application and I can show you some examples. So first of all, let's go to our component. So we have this component, and I basically created the component just to have an easy way to reload my application. But the main thing how we start the server is this bit here. We have this Jetty adapter library included, a Ring Jetty adapter. By the way, let's quickly take a look into depcd and what we're using. So as I said, we can ignore this component, it's just for the substructure. So from Ring, we only need this Ring core and Ring Jetty adapter, and this will bring Jetty dependency as well. And after that, eventually we'll need this Compojure library to implement some HTTP routing. Going back, so yeah, we have this Jetty required, and this run Jetty will actually know how to start the web server and how to add our handler. So the main bit happens here, the create server function, and as we see, the thread pool is created, the Jetty thread pool, to configure minimum, maximum threads, some queue inside. That's options available in Jetty documentation, and usually you want to change some of those if you're building some high load servers. But if you don't care about that and you don't have too much traffic, you don't care about that, to be honest. So we created this thread pool, and after that we create a Jetty server here, and after that we basically have two options. One is to just enable plain HTTP connector, or if we want SSL connector, we can configure it by this parameter. But yeah, basically this will be the default, and it will start the handler on specific port that we provide in the configuration. As you can see here, we say start Jetty on this port, and also we pass our handler here, and here this Jetty adapter knows how to set our handler to the Jetty, and this proxy handler is what I've told is basically know how to convert Ring abstraction into Jetty classes. So that's it about Jetty. If we want really to be really if we want really simple example, let's call this a simple handler, and we don't want params. Let's say simple handler here. And we can just pass it straight into run Jetty, and this will start a web server. If we go here and we do, basically it catches all possible URLs, paths. As you see, we always have this simple handler response. What we can do now is, if we return the request here, let's restart. So we see what we the handler receives and the input params, and it's quite a lot from the headers. So let's just desock headers. so our map is more readable. So yeah, you see we have the port, we have the URI here, and we have the query string nil, we have the scheme HTTP, and we have request method get. Let's do like test. So now we have URI test here, and if we do query param like that, we now will have it as a query string. If we join some query params like b, we still have this bit here. So yeah, that's the simple example. And if we want some custom middleware, we can create something like that. So let's remove this and we'll write it from scratch so you can see better. So we have dfn, my new middleware, right? And it should get the handler as input param, and we want to return a function again that returns that gets the request as input param. And here the main bit that we need is to run to call our handler on top of the request, but we also can update incoming request here, right? So for example, we want let's do sock and let's say middleware my new middleware and some value, for example, hi. And now if we, yeah, so it's not in the chain yet. So to add an interceptor in the chain, fix this call. So to add the interceptor in this chain, we can use the threading macro, and we want to pass our handler to my new middleware like that. And if we reload and refresh, we should see our new key here added. So basically our middleware just updated the request that we received. And again, if we want, we can update the response here, and we can do it like response. So at this point, the response will be just response from our handler that passed here, but we can do whatever we want with the request. Let's just print it for now. Println response, and we need to return the response at the end. So yeah, that's it. Okay, moving next, let's take a look what's available in Ring by default, some useful middleware, and one of the most useful is this one, wrap params, and let's take a look how it looks now. So if you take a look in this query string, you see it's just an unparsed string, and if we want some value from this query string, it will be a bit hard to do it all the time in our handlers. So we want something better, and luckily there is a wrap params interceptor. It comes from Ring middleware params. If we reload and refresh, now we see that we now have these params, and we have our query string parsed by Ring, by the middleware, right? So it looks much better. And also, if it's possible to have multiple query params with same name, if we do like b twice, it will be a vector here. So the other thing is this wrap keyword params, and we want to put it right here. And now if we refresh, now you see that these strings that were keys are now converted to keywords, so it's really easy to use in Clojure. So if we want, for example, get the B value, we can do something like, where's our handler? So it will be request params B, reload, refresh, and yeah, we see this value here. If I change it to something, it will be updated here. So yeah, that's how we use existing middleware and how we combine it to create a handler. So once again, this is the main bit. We start with our simple handler, and then we chain it into middleware that we want to add on top of that. And note that these two are linked to each other. So this one expects that param map from this one. So it should be called in this order. If we change the order here, it will not do the job, this one. It will not convert the keys. Yeah, just my suggestion to understand that better, just try to write your own middleware and just print the steps, and you'll see how it works much better. So far we have a single handler, but obviously in real application we want HTTP routing, and one of the simple libraries that we have is Compojure, and let's take a look how it's configured. So for Compojure, the main bit is here. So we define now these Compojure roots, and then we use this roots function from the compojure.core, and inside we provide these handlers, which defined by a macro, unfortunately, but that will be a single handler here. And Compojure will know how to convert these handlers into Ring format. So how to use that? Instead of our simple handler here, we want our Compojure roots, this bit. And if we reload now, and also you see that we have this fallback now to not found. So it's just a simple handler that will return 404 not found if there is no match in these handlers before that. So let's reload. Now if we do this, it says page not found because this test path is not defined in the root table. If we go to the just slash, it's Compojure root, which is returned by this handler. By the way, the format is you have this block and then you have this get, which is macro. That could be like post, delete, etc. And this is all defined in this compojure.core, and you want to refer them or just use as and require them like that. So this is our root handler, as I said. And here we can just put a body, so that could be inlined here, but a more practical way, as I see it, is just to have a separate functions as handlers and then call them here. So we receive this request, same format, like this, and we pass it into our handler and return a ring response from our handler. If we want to add a new root, for example, we want this user/user ID. This is syntax to define the path param, And now if we reload that and go to users/123, now we'll see these params and extra information from Compojure, which root it is, and yeah, the params is the main thing that we're interested in, and root params is from Compojure. But basically this key params is combined params from different places. So it will include root params, and if we add a query like Q1, it will be added here as well. So yeah, that's an easy example for Compojure. So basically Compojure is responsible for the routing our requests based on the path. And it's not the only library available. So if we go to BD, search for BD, there is a nice library, BD. The difference from Compojure is that BD isn't using macros, and it's bi-directional. The replacement for Compojure could be BD, could be rated. Both are good options. And also there is pedestal, but a pedestal is kind of in parallel to Ring. It builds own abstraction with slightly different approach, which we will cover in next videos. So yeah, I hope I gave some high-level understanding of all the bits. I just encourage you to go check yourself. Both Ring and Compojure are pretty simple libraries. If you dive into the source code, it's not that hard, but mostly focus on the available middleware and what features they provide, and you should be good to go after that. Cool. Hope you enjoyed the video. As usual, like and comment and subscribe to the channel so don't miss new content. Thanks for watching. Have a nice day and see you next video. Bye bye.